Hello, this is the video notes for Unit 1, Lesson 10. I know, what do you know? In this lesson, we're doing a practice understanding, which means that I will give you some information that I know about a sequence, and your job is to add all the things that you know about the sequence from the information that I have given you. Depending on the sequence, some of the things you may be able to figure out for the sequence are maybe find a table, a graph, an explicit equation, a recursive equation, a constant ratio or constant difference, any terms that are missing, the type of sequence, or a story context. Okay, let's go ahead and start. So here we have number 1. It says try to find as many of the above things as you can for each sequence, but you must have at least 4 of the items in the list for each problem. Okay. So I know that the first 5 terms of the sequence are 0, negative 6, negative 12, negative 18, and negative 24. What do you know? So just from that list, I know it's arithmetic. So I'm going to write that immediately. This is definitely arithmetic. Okay, which means it has a common difference of minusing 6. I'm going to do a little table here. So off to the right, I'll do a little table. This is the term, and this is the value. So term 1 is 0, term 2 is negative 6, 3, negative 12, 4, negative 18, then 5, negative 24. So with this, I can write my recursive equation. So it always starts with where we start. So f of 1 equals 0. And then next, that's f of n is previous, f of n minus 1. And then we have our pattern at the end, minus 6. Okay, so that is recursive. Explicit, we'll have our f of n equals, and then our pattern is minusing 6. So I'm going to do negative 6n, and I'm going to do the version with the 0 term. The 0 term is just going to go back one spot, back one spot. So instead of minusing 6, I'll add 6. So the 0 term is positive 6. Okay, so I'll write plus 6 at the end. Okay, so far I've got 1, 2, 3, 4, 5 ways of representing the situation. So I know 5 things. I'm going to add a graph just to round it out. So I'll put my graph over here on the right. Here is my graph for this situation. I'm just going to do quadrant 4 because these numbers have negative y values. So I'll go by ones for x, 1, 2, 3, 4, and then for y, I'll go by, let's say, by tens. So negative 10, negative 20, negative 30. Okay, so when n is 1, f of n is 0, so that's like all the way up here. When f is 2, we're at negative 6. F is 3, we're at negative 12. F of 4 is negative 18. Okay, and then I'll extend this so that you could see what happens at 5. At 5, we're down at negative 24. So it has a very constant rate of change. It's forming a straight line, but I don't connect my dots. All right, let's move on to number 2. In number 2, it says, I know that it is a sequence where f of 1 is 5 and the constant ratio between the terms is 3. Okay, so immediately that tells me it is geometric because it says constant ratio. So it's geometric where r is 3. I'm going to just write my 2 formulas right away. So this is recursive, f of 1 is 5, and f of n next equals f of n minus 1 times 3. Okay, and then here's the explicit. So for the explicit version, I'm going to do the version where it uses the first term. So I'm going to go f of n equals, the first term is 5, and my pattern is timesing by 3, so parentheses 3, and then up in the exponent, since I used my first term, I'll do n minus 1. Okay, here is my table for this situation. So I have n, f of n. So this is going to be 1 is 5, 2 is 15, 3 is 45, 4 is 135, and then 5 is 405. Okay, which means my graph looks like this. I'm going to do the first quadrant. For the x-axis, I'll just go by ones. So 1, 2, 3, 4, 5. And for the y-axis, I want to get all the way up to 405, so I'm going to go by hundreds. So 100, 200, 300, 400, 500. I'll just label all those. Okay, so when x is 1, y is 5, so it's like barely above the x-axis. 2, we're at 15, again, that's barely above. 3 is 45, so now we're like about halfway up to 100. 4 is 135, so we're definitely above 100, not quite halfway to 200, and then for 5, we're all the way a tiny bit above 400. So we've got that curve going on as it's growing. All right. I think that is good for number 2. That gave us 1, 2, 3, 4, 5, 6 things. Yep, I think that's good. All right, let's move on to number 3. For number 3, we are given this graph. All right, so just looking at the graph, I know it's arithmetic. Arithmetic. I know it's going to have a subtraction. I don't know how much yet. I have to figure out how much. So D is negative something. So let's go see if we can find some points that will really help us. So this one is a really good one to help us. You see it crosses the grid really well. That'll help us count. And this one is really good. So it looks like we're going by ones everywhere. So it looks like we drop 2 and we go right 3. Okay, so negative 2/3 is our common difference, minusing 2/3. All right, what else do we know? We know our recursive formula. So our recursive is f of 0 equals, do you see right here on the y-axis, it crosses at 11. So that's our start. And then f of n equals f of n minus 1 minus 2/3. And then let's do our explicit. Our explicit equation, the pattern is negative 2/3. So we go f of n equals negative 2/3. And I'm just going to use the 0 term 11, so I can just do n. Don't have to do n minus 1, just do n plus 11. Okay, I could also add a table here if I wanted to. So let's add that over here. So here's my table for the situation. So I've got f or n and then f of n. So at time 0, we're at 11. I can't really these are gonna be decimals, aren't they? How about if I just do the ones that are whole numbers? At 3, we're at 9. 3, we're at 9. At 6, we are at 7. Here's another one. Here's another one. At 9, we're at 5. And let's do one more. Here's a really good one. At 12, we are at 3. Okay, so that's kind of seeing that 2/3 drop, right? Because it's minusing 2 for every 3 that we're going right. So negative 2/3 is our common difference. All right, let's move on to our next one. Number 4. I know that the explicit equation for the sequence is f of n equals negative 10 times 3 to the n minus 1. Okay, what do we know? So because of this right here, I know that this is my first term. And because the n minus 1 is in the exponent, I know this is geometric, and that is my common ratio. So let's go ahead and list those things. So we know it is, number 4 is geometric. We know we have a common ratio, r is 3, and then we could write our recursive formula, which will be f of 1 equals negative 10, and then f of n equals f of n minus 1 times 3. Okay. Let's go ahead and create a table for this, and then a graph. So here's going to be the table for it. We have n and f of n. So at time 1, we're at negative 10 times 2, we're at negative 30. 3, we're at negative 90. 4, we're at negative 270. And 5, we're at negative 810. Okay. So this graph, I'm just going to do the 4th quadrant because of these negative y values. So that's the 4th quadrant. Looks like for x, I can go by ones. 1, 2, 3, 4, 5. And looks like for y, I want to go all the way up to like negative 800. Well, I guess I don't have to have my 5th term graphed. How about I go up to, I think I could fit it on here. Negative 100, 2, 3, 4, 5, 6, 7, 8. There's negative 800. So I'm going by hundreds, right? I'm just going to label a few of them so I remember what my scale is. All right, so now we'll graph them. At 1, we're at negative 10. It's just like right below the y-axis. At 2, we're at negative 30, just barely below as well. At 3, we're pretty much right at 100, just right before it. At 4, we're at negative 270, so that's almost negative 300. Let's like put it right there. And then at 5, we're all the way down at 810, negative 810. So like right there. Okay, so that's what our graph looks like. Again, not connecting the dots, but we do see that curve going on. All right, let's move on to number 5. All right, number 5 says, I know that the recursive equation for the sequence is f of 1 equals negative 12, f of n equals f of n minus 1 plus 4. Okay, this right here tells me arithmetic because of that plus 4. So let's write that down. So this is arithmetic. D is 4. Let's write our explicit formula. So explicit is f of n equals, and they gave me the first term, so if I'm going to use the first term, I need to write negative 12, and instead of n, I'm going to do parentheses n minus 1, because, oops, I just did a mistake. The pattern has to go in front, right? The pattern is timesing by is adding 4. So 4, right? It's dn. So that's my pattern. My variable has to be n minus 1 because it gave me the first term. So then I'll go minus 12. I'm going to build a table for this before I show you the other version of explicit, just so that I get it right. So here's my table. N, f of n. So the first term is negative 12. And then it says we're adding 4. So the second is going to be negative 8. The third is going to be negative 4. The fourth is going to be 0. The fifth is going to be 4. Which means if I want the 0 term for my explicit formula, I have to go backwards one spot. Instead of adding 4, I'll minus 4, and I get to negative 16. Okay, so this will be like the alternate explicit formula. If you like using the 0 term, this is for you. F of n equals 4, and instead of n minus 1, I'm just going to do an n because I'm going to use minus 16. I'm going to use my 0 term there. Let's go ahead and graph this to see what the graph would look like. So I'm going to graph this kind of quadrants 1 and 4, because it kind of will start going from negative y values into positive y values. For x, I'm just going to do 1s, 1, 2, 3, 4, 5. And for y, I'm going to go by 2s, I think. 2, because I have to get all the way down to negative 12, negative 2, negative 4, negative 6, negative 8, negative 10, and negative 12. So that's going by 2s. And up here, I'm going to go by 2s as well. All right, so 1, negative 12. So right there, 2, negative 8. So that's going to be right there. 3, negative 4. About right there. And 4, 0, 5, 4, 5, 4. Okay, so definitely linear, which is arithmetic, right? Straight line, but do not connect the dots because it's a sequence. All right, let's move on to number 6. For number 6, I know that the sequence models the value of a car that originally cost $26,500. So that was like at times 0. So I'm going to call this f of 0, but loses 10% of its value each year. So that's definitely, this is geometric, right? It's a percent. So R is going to be what is kept of the value. We lose 10%, but we keep 90%. Keep 90%, which means that R is 0.9. Okay, so let's fill in what we know. We know that this is geometric. This is number 6. Geometric. Okay, we know R is a 10% loss, which means we're keeping 90%, 1.9. We know so this is recursive. We know at time 0, the car cost $26,500. And we know the next is the previous times our value that we're keeping, 0.9. And then let's do our explicit. Explicit, f of n equals our 0 term times 0.9. And in our exponent, we just need the n because 26,500 is our 0 term. Okay, let's show what this looks like in a table and a graph. Okay, so here's our table. So n, f of n at time 0, our car is 26,500. At 1 year, it has dropped to 23,000. 3,850. At 2 years, the values dropped to 21,465. All I'm doing is multiplying by 0.9 to get these numbers. And then at 3 years, it's less than 20,000. It's 19,318. Okay, let's show what that looks like in a graph. So this is definitely going to be first quadrant. For X, this is just years, so I'll go by ones. 1, 2, 3, 4. And then for Y, I need to be all the way up at 26,500 for my maximum. So I probably need to go by maybe up to like 30,000. Should I go like every 10,000? That seems like a lot to go by. So this is 10,000. This is 20,000. 30,000. Okay, so times 0, 26,500. So that's like a little bit more than halfway. And then at year 1, like halfway between that and 20,000. Year 2, we're just above 20,000. And year 3, we're just below 20,000. So definitely a gentle curve because it's only 10% loss each year. All right, let's go ahead and move on to number 7. Number 7 says, I know that the first term of the sequence is -2 and the fifth term is -1/8. Okay, so it means we're missing a whole bunch of terms. So let's see. I think this one could be geometric or could be arithmetic. So I'm actually going to first solve it arithmetically and see what we get. And then I'm going to solve it geometrically and see what we get. So I'm going to have like 2 ways that we solve this. So let's try arithmetic first. So arithmetic. So we know the first term is -2. So let's go ahead and build that in. N, F, F, N. First term, -2. Second, we don't know. Third, we don't know. Fourth, we don't know. But we know the fifth is -1/8, which is also -0.125. Okay. So to find missing terms in an arithmetic sequence, we need to subtract the 2 terms that we know and then divide by the number of jumps. Looks like there's 4 jumps. So which gives us a common difference of 0.47 added each time, which means we can write the first term is -2. This is our recursive formula. And then the next is the previous, f of n minus 1 plus 0.47. Or we can write the explicit. So f of n equals 0.47, and since I have the first term, I'll do parentheses n minus 1 minus 2. Okay, so that's if we treated this arithmetically. So let's see what if we treated this geometrically. What would it look like? Okay, so let's say it was geometric. Okay, so if it was geometric, let's do the table for that. N, f of n. The first term is -2. The second, we don't know, third, fourth, fifth, but we know the fifth is -0.125. So if you treat it geometrically, you divide the last by the first, and then you're going to take the root, the fourth root, right? 1, 2, 3, 4. Yeah, you're going to do the fourth root of whatever that division is, -0.125 divided by -2. All right, when you do that, you get a pattern of 1/2. So R could be 1/2 or 0.5. Oh, that's interesting. R can also be -0.5. Okay, and the reason why I'm saying that is we can have a positive, then a negative, and then a positive and a negative. And it goes back to what we know. So this has lots of answers for this one. All right, let's write our equations. So this is recursive. F of 1 is -2. And then we have f of n equals f of n minus 1 times 0.5. Or if our pattern was -0.5, we could have f of n equals f of n minus 1 times -0.5. Okay, let's do our explicit. For explicit, they gave us the first term, so we'll say f of n equals -2 times 0.5. And because we have the first term here with the -2, and the exponent will have n minus 1. Okay, or it could be f of n equals -2, and our pattern could be -0.5, and still with our exponent of n minus 1. Okay, so that was number 7. I think we're going to just stop with those and not worry about graphing, because we've got 1, 2, 3, 4, 5 representations for each. And for geometric, we've even got more than that. So we're just going to leave it there. Okay, let's go ahead and move on to our takeaways. Our takeaways is this big table where it talks about what do you know and what can you find out. So if it gives you if given a table, what do you know? So that is our first one. So if they give you a table, right away you can see our starting term. Okay, and that could be f of 0 or f of 1. What can we pretty easily find out? We can pretty easily find out the pattern, whether it's the common difference or the common ratio. We could pretty easily graph it because they gave us the table, and we can pretty easily find our equations. Okay, let's say they give us a graph. From the graph, it's really easy to pick out the type of sequence. So that's really easy to see. So if you have a straight line pattern, it's arithmetic. If it's a curve, that is geometric. What can you find from a graph? It's pretty easy to fill in a table. It's probably pretty easy to find the equations as well. Once you have your table, you can see the equations and your patterns. I'll write pattern as well. Okay. All right. What if they give you an explicit equation? From the explicit equation, it's very easy to see the pattern. That's given like right away, and it's also easy to see the starting term, which could either be f of 0 or f of 1, depending on what variable you see, right? If you see just n, then that's giving you the 0 term. If you see n minus 1, then that's giving you the first term. I just realized I made a mistake here. F of 0 or f of 1. There we go. All right. What can you find given an explicit equation? You can find a table. You can use your table to graph it. You can find the recursive equation. Okay, and pretty much everything else. All right, last one. Given a recursive equation, what can we find? Or sorry, what do we know? And then what can we find? So given recursive, we right away know the pattern, and we right away know the starting term. Whether it's f of 0 or f of 1. What can you find? You can easily create a table. You can easily create a graph. And you should easily be able to do your explicit equation. You should also pretty easily be able to see your type of sequence. I'm going to add that for both of these. Type of sequence should be pretty obvious from an explicit or recursive equation. In this lesson, we found efficient strategies for identifying, representing both the type of sequences we've been studying. Whatever information is given, we sharpened our skills in finding the first term and the common difference or common ratio in any representation, and how to use one representation to find another. I hope this was a helpful video. I wish you good luck on your practice.